purpose of this demo is to illustrate how we can load and execute a program that draws a rectangle at the top left corner of the screen. So what we have here is two windows. In the foreground I have the CPU emulator, and in the background I have a plain text editor with the program in question loaded already into it. The program has been written. If we read the documentation, we see that the program claims to want to draw a rectangle at the screen's top left corner, and hopefully that's also what the commands of the program are actually doing. We can scroll through this program and see all sorts of familiar hack commands written in the symbolic hack machine language, along with documentation and white space to make the code more readable and manageable. So let's go to the CPU emulator and click the load program button, which is right here, and look for this program, Rectangle.asm. Here it is. Found it, loading it. And it's interesting to contrast the source code with what was actually loaded into the CPU emulator. So let's take this window and put it right next to the loaded code. We see that the source contains all sorts of symbolic addresses like @R0, @N, and so on. Now all these symbolic addresses are being translated on the fly into their concrete numeric semantics. So if we look at the code that was actually loaded into the CPU emulator, instead of @R0 we see @0, instead of @N we see @16, and so on and so forth, according to the rules of translation of hack symbolic programs into machine language. This is something that we are going to learn in Unit 6, so please don't worry about it for now. If you want to understand how a program works in the CPU emulator, it's better to look at the source code and not at the code that was actually loaded into the emulator. So you run the program in the emulator, but you inspect and debug it in the text editor, and then you reload the corrected version in order to continue to test it. All right, so let's put this window roughly back where it was before and go back to the CPU emulator. And once again, the program is loaded. We are told that we have to determine the depth or the length of the rectangle by filling in some number in RAM 0. So let's do that. And I'm going to put here the number 50. So we are going to draw a rectangle which is 16 bits or 16 pixels wide and 50 rows long. Hopefully that's what the program is going to do. So I can start executing the program by clicking this play button, and each time I click a play button I execute the next command in the program, and so far nothing seems to happen, but perhaps we have to be slightly more patient. And indeed we see that we drew one line of 16 pixels at the top left corner of the screen. Very nice. So let's continue to execute, and looks like there was a loop in the program, and I'm doing it slightly more quicker, and I see that I drew another line and keep on drawing another line, and so on and so forth. If I get tired of this stepwise simulation, I can click the fast forward, and then I can just sit back and watch the program get execute. This is fairly slow, so I can make it faster by using this slider here. And I see now that the program runs much quicker than before, and it keeps on drawing rows until the counter of these rows will reach RAM 0, which now happens to be 50. And that's it. We got this limit. And at that stage, the program executed some goto command that sent it to the end of the program, where it runs an infinite loop. And that's exactly what I want to do at the end of every hack program. So once I get tired of seeing this infinite loop, I can stop the program, look at the screen, and convince myself that the program has actually done what it was supposed to do. Now, let's scroll back to the top of the program, and we can try some other input, let's say 70, or let's even make it more a larger number. So we're going to draw a rectangle which is 120 rows long. And if I'm tired to see all this animation, I can click this control here and cancel the animation, at least temporarily. And then I reset the program. And once I've canceled the animation, I can simply click fast forward, sit back, and watch the program execute in an instance. So let's do that. And as you see, a rectangle of 120 rows by 60 pixels has been drawn so-called instantaneously. Of course, as a low-level programmer, you know that this program required 120 iterations, and in each iteration we had to execute several machine-level commands. So this has been a demo in which we illustrated how to use the CPU emulator in order to execute a graphics-oriented program.